For our statistical research project, we chose to look into the topic of unemployment, specifically GDP per capita versus unemployment rate.
For our variables, we chose two we believe to be strongly linked, the independent being Canadian GDP per capita in USD, and the dependent being unemployment rate. To connect these two together, we decided to use years as our linking variable.
For our two strata, we chose to use gender and do male and female. We felt that these were the most obvious strata to use for the data set we had.
For some insight on our topic, unemployment is currently a worldwide problem. Unemployment rate is the percentage of people in the labor force who currently do not have jobs. Canada's unemployment rate has been hitting record highs in the last decade, reaching 13.7% in May of 2020. Unemployment can be caused by a number of factors, one of which we believe is GDP. GDP per capita is a measure of the dollar value of goods and services outputted per person.
Now, you may be wondering, why is this topic important? Or who is going to use this information? This information is valuable because it highlights the importance of employment. Depending on how GDP changes in relation to the unemployment rate, it can show that either employment is essential or unessential to our economy. Also, the information can demonstrate the overall economic state of our country, which can allow us to predict future trends, create new jobs, and much more. Some jobs that use this information will be those related to economics, business, policy, and finance. They all use this information to consult, predict, or assess the country's wealth in some way in order to help their careers or clients.
Now let's take a look at some of our data, starting with the histogram of our female strata. This histogram shows the frequency of the different unemployment rates from 1993 to 2023. The highest interval being 7% to 8% shows that over the course of this period, most of the unemployment rates were between those two percentages. From this, we can determine that our mean unemployment rate will most likely be around that number.
Moving on to our male strata histogram, we can see that for the most part, the frequencies are closer together and less variable compared to the female strata histogram. The highest interval on this histogram is 6% to 7%, which means our mean will most likely be around that number. In addition, on this histogram, although the scale does go all the way till 12, there is zero frequency there, meaning it will have less outliers in the female strata.
Using a box and whisker plot proved to be a great way to visually represent and identify the outliers in our data. On the box and whisker plot, the holes not connected by whiskers represent them in either the upper or lower quadrant. This was important to note because outliers can skew our data and change the results of our calculations. The box and whisker plot also represented our median and quartiles. As you can see, the median for the male strata is at the same point as the lower quartile of the female strata, which can show the difference between the two data sets.
Mean and median are two very valuable calculations to perform when comparing two variables. Depending on what's being evaluated, it can sometimes be more accurate to pick one calculation to use over the other. Specifically when dealing with the mean, if outliers are present, it can pull it up or down. For our project, after calculating both, we chose to use the median to examine our data because it didn't include the outliers that were pulling our mean too high. This median allowed us to draw the conclusion that men tend to get more jobs than women since they have a lower median unemployment rate.
Standard deviation is the measure of spread. The lower a standard deviation, the more clustered together points are, therefore indicating consistency in variation. In our data set, it shows how the unemployment rate for men was more consistent because it was lower than female standard deviation.
When looking at our scatter plot, there are a few key things to point out. Firstly, how the points are distributed. At the beginning of the graph, the points were very clustered together, but as you look more to the right, they start to become very spread out. This could indicate that we were extrapolating and the trend doesn't continue as far as we thought. Second, there are more blue female points that are outliers than there are red male points that are outliers. When it comes time to calculate the correlation coefficient, it is important to know that this will most likely cause a lower correlation. Lastly, the line of best fit has a positive slope, which will result in a positive correlation. When making conclusions, this will help us determine the relationship between our independent and dependent variables.
For the final step in our project, we had to calculate the correlation coefficient. This was debatably the most important part because it helped us describe the relationship between our independent and dependent variables. Our correlation showed to be moderate and positive, which allowed us to determine that the higher the GDP is, the higher the unemployment rate will be for that year. With this statement, it is important to note that our R value is not that strong with only moderate correlation, which could mean that our conclusion is incorrect due to the lack of a strong relationship between our independent and dependent variables.
In conclusion, the unemployment rate will continue to be an issue as our economy grows and changes. There are a number of factors other than just GDP per capita that can contribute to this issue and will continue to do so. By gathering our information from credible sources and keeping an impartial view, we hope to have provided some insight into this important topic and hopefully some opportunities for a solution.